The next advanced function we'll talk about is called as anonymous function. It's related to function handles. It's a simple one-line function, and you don't have to save the function definition in a separate file. So let's see the syntax of it. So you write the function name right away. So here I'm having circ area equals to @. So that's how you start an anonymous function definition. And then in the parenthesis, you have the input variable, and then you have the one-line function code. Okay, so which here it's evaluating the area of circle. So I could simply say circ area of 3 and get the area of a circle with area 3. Now let me write a function to compute the area of a rectangle. So that would be area rectangle equals to @. Length and width are my input arguments, and then the way I evaluate it is going to be length multiplied by width. As simple as that. If I say area rectangle of 3, 4 and run it, it's going to evaluate it. So let's look at both of these variables in the workspace. If I look at the class of circ area, MATLAB tells me that it's a function handle. Now function handle, like the name suggests, is like the handle for a function. It can be extended to regular functions that you see. For instance, I could say s equals to @size. Now s is a function handle of the function size. Okay, so I could simply say s of zeros 5 by 5, and then it's going to give me the size of the zeros 5 by 5 matrix. Just to give you one more example, I'm going to make L as the function handle for length. Now, L of zeros 5 by 5 would be 5. Recursion is a beautiful mathematical and programming concept. It lets you create mathematical art like this. Can you believe this was created using a single function? All right, so let's look at these fractals in more detail. Now, all these highlighted regions are having the same structure. You can pause the video right here and then see the structure unfold. Okay, so basically, now let's look at this concept unfold in this MATLAB function called as recursive factorial. Okay, so I'm trying to evaluate factorial of the value of 5. So let's see what's going to happen when I input the argument, n equals to 5. So because n is not equals to 1, the else condition is going to be executed. So I'm going to have 5 multiplied by recursive factorial of 4. It enters again, and then I'm going to have 4 multiplied by recursive factorial of 3. It enters again. 3 multiplied by recursive factorial of 2. It enters again. And finally, n equals to 1. That's when my factorial value is going to be 1. Now let's visualize what's going to happen when we execute this on MATLAB command prompt. So if I say factorial of 5, I'm going to have 5 multiplied by factorial of 4, 4 multiplied by factorial of 3, 3 multiplied by factorial of 2, 2 multiplied by factorial of 1. Sorry to annoy you. And then finally, factorial 1 is going to give the value 1. And it's going to propagate back that way. Finally, it computes the 5 factorial value. So I request you to look at this program. It's posted to Blackboard, and come prepared for next lecture. See you soon.